B. 1000x to 999. C, you notice I used a lot of my different notations here, but all these represent derivative. F prime, y prime, dy dt just means the derivative of y in terms of t, so that would be d over dr of the r cubed, which is just saying the derivative of r cubed. So we got this. A little bit faster than doing the full definition each time. So we're kind of now entering the section where we are going to learn rules to help us on all these problems. Okay, let's take a look at these. They're a bit different. The only rule we have right now allows us to do the derivative if it is just x to a power. So I can't do this derivative unless I can rewrite the problem as x to a power. 1 over x squared, is there any way to rewrite that? X to the negative 2. So the derivative, f prime of x, exponent comes down, so a negative 2x, and then if you subtract 1, this is where people always mess up. What's negative 2 minus 1? Okay. So first, rewrite your problems. On B, is there any way to rewrite that as x to a power? So for the derivative, exponent comes down, x, subtract 1 from the power. So 2/3 minus 1, negative 1/3. Any questions so far? We have talked about tangent lines and secant lines. The one thing that we have not looked at yet are normal lines. Sometimes I may ask you for the equation of the normal line. It is a line going through a point that is perpendicular to the tangent line. So for instance, if I were to take this curve, this line right here would be the tangent line. This would be the normal line. Is this not on your notes?
Yeah, it's on the slide that we started with the rule.
Oh, sorry. I think, yeah, I was trying to save a sheet of paper, so I moved it up to the earlier slide. So you have this definition on the earlier slide where we put a star next to it. Thank you. Now, we can do this the same way that we have been working to get equations of tangent lines. We would do the derivative. The derivative tells you the slope of the tangent line. Since the normal line is perpendicular to that, what do you know about perpendicular lines? How are their slopes related? Perpendicular? Opposite reciprocals, aren't they? So if the tangent line had a slope of 2, the normal line would have a slope of negative 1/2. You have to flip it and change the sign. So if I ask for the normal line, you are going to do all the same steps we did for tangent lines. So you're going to do your derivative. You're going to plug it in and get the slope. But then we have to do the opposite reciprocal of that before we move on. Okay, so we need equations of both the tangent and normal lines to the curve f of x equals x square root of x at the point 1, 1. Okay, right now, I cannot do this derivative unless I went back to my old definition like we did on the quiz. Anybody want to go back to that? It wasn't necessarily hard, but it was time consuming, wasn't it? We're looking for faster methods now, so we can do more of these. I have to rewrite this as x to a power if I'm going to be able to do the derivative. How would you rewrite the square root of x? So if I multiply these, what do you do with your exponents? Add them. And so 1 plus 1/2, this would be x to the 3/2. So now we can do our derivative. Exponent comes down, 3/2. Subtract 1 from the power, 3/2 minus 1 will be 1/2. So that's our derivative. I need equations of the tangent and the normal line. So for the tangent line, the derivative represents your slope. So if you plug in a 1, 3/2 times 1 to the 1/2 power is what? One to the 1/2 just means the square root of 1, which is 1 times 3/2 is 3/2. Okay, now we have a point and a slope, so we can write our equation. So 1 equals m times x plus b. Subtract over your 3/2, you get negative 1/2 for the y-intercept. So the equation is y equals 3/2 x minus 1. Alright, so the normal line, the only thing that's going to change is your slope. So this one we use the slope of 3/2, so what slope would we use for the normal line? And then you're doing the same thing, plug into y equals mx plus b. And your 2/3 over. Any questions? You guys try one. I want just the normal line this time. But you'll have to give the derivative for the slope of the tangent line to start. And then you got a little unsure. So derivative is 4x cubed. To find the slope of the tangent line, you have to plug in your negative 2. Which gives you a negative 32. For the normal line, the slope is the opposite reciprocal. So you have to flip that and change the sign. So it's 1 over 32. And we still have the point negative 2, 16. So now plug into y equals mx plus b. So if you add that over 257 over 16 for your y-intercept. So final equation y equals 1 over 32x plus 257 over 6. And again, that is the normal line. Questions? That's not 6, that's 16. Questions on that? So I just want to extend on this derivative piece a little bit and learn a few other rules. I may prove some of them, I may not. We'll kind of see how it goes. So I kind of gave this one away already on the example I gave you at the beginning when I did the 3x to the 21st. But if you have a constant times your function, you can pull that constant out in front and then just do the derivative. So what that's saying is if you have like a 5x to the third, then the derivative, that 5 just trails along, and then you do the derivative of x cubed, which would be 3x squared, and multiply, so you really just get 15x squared. So, in other words, if you have a coefficient, it's not going to change anything. You still do the derivative of x by like normal, and then just multiply that coefficient back in. I'll prove this one, just for fun. You guys like the proofs, right? If we wanted to go back to our definitions, let's say our function as some function g, and that is just a constant times another function. Then if we do our definition, when it's h approaches 0, we're going to do f of x plus h minus f of x over h, right? Or in this case, I guess g is our function. So that's the actual definition. So g of x plus h, since g is equal to this, that's just a constant times our f of x plus h minus our constant times f of x all over h. Since both of those terms have the constant, you could factor it out in front. We know that with limits, when we first did limits, you could always pull those constants out in front of the limit as well. So I have c times, and this is the definition of f prime. So we proved that the derivative of g is just that constant times our f prime. Questions there? So let's try a few. The derivative of 3x to the 4th, what would that be? Derivative of x to the 4th is just 4x cubed times our 3, so this is 12x to the 3rd. On B, derivative of negative x. This is like x to what power? 1 right now, so if you bring that exponent down, it's negative 1 x to the, and anything to the 0 power is 1. So this is -1 times 1, which is -1. I want to do a few more extensions of this, and then we'll be wrapping up for a day after a few more examples. The next piece, and I left space to prove it, but I'm probably not going to prove this one unless you guys really want me to. The sum rule says if you have the derivative of multiple things added together, you can do the derivative of each piece individually. So another way we might see it written, f plus g prime, it just means f prime plus g prime. This allows us to do the derivatives of polynomials. It's just saying you do the derivative of each term and add those together. Do you guys want to see the proof of that? Okay. I'm going to skip that. The same is true when you are subtracting. It's just the derivative of f minus the derivative of g. So now we're really getting into the things that could save us a lot of time. Because if you think when I gave you the derivative of x cubed plus 3x squared, you had to cube that out and it took a long time. It got really messy in the middle. Now we're saying you don't have to do all that anymore. We can just do this derivative. So this would have been one that would have been nearly impossible for us to do by hand. Not impossible. It would have taken a very, very long time to do like x plus h to the 8th power and try to simplify all that. But now I'm saying the derivative, we just do each piece. So what's the derivative of x to the 8th? Plus the derivative of 12x to the 5th. Yeah, when you bring this 5 down, you really just multiply it with the 12. So 5 times 12 is 60. X, and then subtract 1, so it's to the 4th power. Minus 4 times 4 is 16. Subtract 1, x cubed. Plus 30x squared. Minus, what's the derivative of 6x? Just be the 6, yeah. What's the derivative of a constant? It's 0. We did that at the beginning of class, well, right after the quiz. That was the first thing in this section we talked about. Derivative of the constant is 0, so we just dropped that. So there's our derivative. Much faster. Now you know how I could look at yours and immediately tell you if you've done your derivative right or not. Two more examples. So I want all the points where this tangent line is horizontal. What does it mean if the tangent line is horizontal? Slope is 0, right? Slope of a horizontal line is 0. How do we get the slope of a tangent line? Derivative. So let's start with the derivative of this. So y prime, what would this derivative equal? And plus 0, so I'll just leave that off. Okay, I want everywhere this is horizontal, so you said that's when the slope is 0. So now we're going to solve this. What do you notice about these two terms? That leaves us with x squared minus 3. Set each piece to 0. So we get x equals 0. And x squared equals 3. So if you want to solve for x, you do square root plus and minus, so x is plus and minus radical 3. If I ask for the points, like as in order pairs, could you give those to me now? We know there's 3 of them. There's one when x is 0, one when x is radical 3, and when x is negative radical 3. If I wanted the y values, where would I have to plug those things in? To the original. If you put in a 0, what do you get out? 0 plus minus 0 plus 4, so 4. If I plug in a radical 3, so radical 3 to the 4. So radical 3 times radical 3 is 3. So that would happen twice, so 3 times 3 would give us 9. Minus 6 times radical 3 squared is 3. So 9 minus 18 plus 4 is negative 5. If you put in a negative radical 3, if you take a negative to the 4th, you still get positive 9. A negative squared is still positive 3. So we again get negative 5. So those are the 3 times that this curve had a horizontal page. I'm going to have you guys do the next one. I just want to refresh one thing. This is asking you for acceleration. How do you get acceleration? Second derivative. So you're going to have to do your derivative twice. So go ahead and try this, please. So first derivative, 2 times 3 is 6t squared. 5 times 2 is 10t. Derivative of t is just 1, so this is just plus 3. That's first derivative, which is velocity. Second derivative, 2 times 6 is 12t. Minus 10 times 1 would be 10, and the derivative of 3 is 0. Then I asked for the acceleration after 2 seconds, so plug in your 2. And we get 14. Do you guys know what the units would be? Meters per second squared. Okay, we are stopping here. I am going ahead and assigning certain problems for tomorrow. So I want these done tomorrow, and then we will add to it. If you look at your slides, the very last slide has the homework. You are ready to do this portion. 3 through 17 odd, 23 and 29. So you've got 15 minutes to work on those right now.